Dear students, welcome back to my video coaching. Myself S.N.PATI. My students call me PCM Allrounder because I am teaching physics, chemistry and mathematics for plus 2 science first year, second year and CBSE 11th 12th students since 30 years. Subscribe my channel, watch my video and verify my statements. I am confident that my videos will make your funda clear and increase your answering skill in physics, chemistry and mathematics. Now, today's class. Okay students, now we will discuss main relations. This chapter relations, before entering into relations, we have discussed about ordered pair and Cartesian product. Now we enter into relation. Look at what is the definition of relation. The definition of relation is if A and B are two non-empty sets, then any subset of A into B is called a relation from set A to set B that is represented as R such that A arrow mark B. So if R is a relation from A to B, then R is a subset of A into B. Very simple thing. Relation from set A to B is subset of A into B. Similarly, we can define a relation from B to A. That will be the subset of B into A. This relation will be the subset of B into A. This relation will be the subset of A into B. Similarly, we can define relation from A to A. That will be the subset of A into A. This is the basic definition of relation. We know product of the set contains order pairs. Product of the set contains order pairs A1, B1, A2, B2, A3, B3. So clearly, relation set will also contain order pairs. And we say here A1 is related to B1, A2 is related to B2, A3 is related to B3, and those are symbolically represented as A1 or B1. This we will read as A1 related to B1, A2 related to B2. In generally we say A related to B, where A belongs to first set capital A, B belongs to first set capital B. If we will define a relation B into A, then it will be BA or B related to A. Very simple things. Now look at a small question. Let's set A is equal to 1, 2, B is equal to AB. So let us write a set 1A, A1. Is this a relation from A to B? Look at 1A, A1. Is this a relation from A to B? No, because A into B will contain 1A but does not contain A1. So this is not a subset of A into B. So this is not a relation from A to B. But if I will write 1A, 2B, look at, is this a relation from A to B? Yes. If you will write A into B, then we can see that this 1A, 2B is a subset of A into B. So this is a relation from A to B. Now think that, is this a relation from B to A? No, because B into A contains A1 B to A to B1. So this is not a subset of B into A. So this is not a relation from B into A, but this is a relation from A to B. Now look at another relation, another set, A1 to B. Now is this a relation from A to B? No, because A into B will contain 1A. Here there is A1. A1 is not present in A into B. So this cannot be a subset of A into B. So this is not a relation from A to B. Similarly, check the reverse. Is it a relation from B to A? So look at B into A contains A1. A1 is there, but B2 is present in A into B, but the relation contains 2B. So this is not a relation from B into A. Clearly, this is not a relation from A into B, or also this is not a relation from B into A. I hope you get the ideas which is a relation, which is not a relation clearly. Now come to a point, phi. Phi is a set, we know phi is an empty set. So is phi is a relation from set A to set B? Think, is phi is a relation from set A to set B? Answer is yes, because we know from 10th level phi is a subset from any set to any set. So if phi is a subset from any set to any set, then phi will be a relation from set A to set B, whatever may be the values of A and B. Okay. Relation ro definition very simple kouchi. Ame jodi set A ru set B ko relation lekhiba. Relation is a subset of A into B. Similarly, ame jodi set B ru set A ko relation lekhiba, that will be a subset of B into A. तेणु रिलेशन जदि लिखिबा रिलेशन सेट निश्चित भावे ऑर्डर पेयर को कंटेन करिवो सही ऑर्डर पेयर गुडा फर्स्ट एलिमेंट ता फर्स्ट सेट भीतर निश्चित भावे प्रेजेंट थिबो सेकंड एलिमेंट ता सेकंड सेट भीतर निश्चित भावे प्रेजेंट थिबो एंड आमे कोन करिबा ताको शॉर्टकट रे रिप्रेजेंट करिया पे A रिलेटेड टू B और A1 रिलेटेड टू B1 A2 रिलेटेड टू B2 लिखि परिबा A1 A2 सब सेट A रे एलिमेंट सेबे B1 B2 सब सेट B रे एलिमेंट सेबे एंड गुड एग्जांपल देखिए हमें चेक करें की रिलेशन और की रिलेशन नहीं। फाइनली मन रखिबा एम्प्टी सेट फाइ निश्चित भावे गुड रिलेशन फ्रॉम सेट A to set B whatever may be the set A and set B because 10th class में पढ़िछो फाइ सेट is a subset of any set subset माने ओडिया रे उपसेट so set A set B जहां आले भी फाइ सबसेट हुए so फाइ is a relation from set A to set B. Now the discussion point is how many relations are possible if cardinality of A is equal to M, cardinality of B is equal to N, then how many relations are possible from set A to set B? Look at, we know cardinality of A into B is equal to Mn, number of elements present in A into B is equal to Mn, then how many subset of A into B can exist? Remember 10th class knowledge, set theory knowledge, if any set, remember a point, if any set contain X elements, then the number of subsets possessed by this set will be 2 to the power x. Can you recall from previous things? If set A contains x elements, then how many subsets is possible? 2 to the power x subsets is possible. Similarly, if A into B contains Mn elements, then how many subsets are possible? 2 to the power Mn subsets are possible. So if 2 to the power Mn subsets are possible, then clearly number of relations from set A to set B is equal to 2 to the power Mn. Okay, so if set A contains n elements, set B contains n elements, then number of relations from set A to set B is 2 to the power mn. Similarly, what will be the number of relations from set B to set A? That is also 2 to the power mn, because m into m and n into m are same things. Okay, let us take set A is equal to 1 to B is equal to A. How many relations are possible? 2 to the power mn, m is equal to 2, n is equal to 1. So 2 to the power 2 into 1 is equal to 2 is equal to 4. If set A is equal to 1, 2, set B is equal to A, the number of relations possible is equal to 4. So look at what are those 4 relations. That is, first phi is a relation from set A to set B, whatever may be the set A and B. Then another relation is 1A, this set is a relation. Then another relation is 2A, this is a relation. Then another is 1A, 2A, this is a relation. These are relations or not? According to the definition, all these 4 are relations. Now think, is there any extra relation? Apart from these 4, is there any extra relation? No, there is no extra relation possible for this set A and this set B. So conclusion is the set contains 4 elements. Similarly, take another thing, that is equal to A is equal to 1 to B is equal to AB. Here, what will be the number of relations? The number of relations will be, according to the definition or according to the formula, the number of relations here will be 2 to the power 2 into 2, 4. 2 to the power 4 is equal to how much? 4 into 4 is 16. Here we can write 16 relations. Try to write the 16 relations for this case. Then refer to the note where I have given all the 16 relations. Which particular set A as the nth element, set B as the nth element, A into B have mnth element, and we know if A into B mnth element, the number of subsets is 2 to the power mn. So we take an example, set A, and we see that a number of relations 2 to the power mn formula use kale 4 hochi and 4 relation ame likhi dekele. Similarly, this case re formula apply kale 16 relation hochi. Nije lekhi sariba pore video re dekhiba mo 16 relation lekhichi. Okay. Now pause the video and write the note. Now pause the video and write the note. Now pause the video and write the note. Now we will discuss representation of a relation. How a relation is represented. A relation is represented in 3 forms: roster form, set builder form, by arrow diagram. First is roster, second is set builder, then is arrow diagram. What is roster form, students? Roster form is writing all the order pairs of relation. We have to write all the order pairs present in the relation, that is roster form. Then what is set builder form? Set builder form is we will write a formula such that it can represent all order pairs of relation, that is set builder form. All of you know this roster form, set builder form in set theory chapter. Then the third method of representing relation is arrow diagram, by arrow diagram. Arrow diagram means we will just give an arrow between the 2 elements which are related. Look at, taking an example, I will show how a relation is represented with help of roster form, set builder form or arrow diagram. Look at the example. A is equal to 9, 16, 25. Okay, set A is equal to 9, 16, 25. Set B is equal to 5, 4, 3, minus 3, minus 4, minus 5. So, let us think about a relation in which elements of A are square of the elements of B. Relation is given by elements of A are square of elements of B. Now, if I will write this relation in roster form, means I will write all the order pairs which obey the clause elements of A are square of elements of B. Then what we will get? We will get 9, 3, 9 minus 3. Elements of A are square of elements of B. Similarly, we will get 16, 4, 16 minus 4. Similarly, we will get 25, 5, 25 minus 5. These are the elements of the relation given as described here. This is the roster form. Then what is the set builder form? Set builder form means we will represent a formula which indicates or which concludes these elements present in the relation. What is that formula? Very simple. This is a set containing the elements xy such that x is equal to y square. It is given elements of A is square of elements of B. So we have taken x elements of A, y elements of B. So we will write x is equal to y square, where x belongs to capital A, y belongs to set capital B. Or we can write here AB. The order pairs can also be represented with the help of the set AB such that A is equal to B square. Elements present in first set is square of the elements present in second set. Where? Here we will write where small a belongs to capital A, small a is the element, A is the set, and small b belongs to capital B. Okay. This is the set builder method to write the relation. Then what is the arrow diagram? Arrow diagram is very simple. Just take set A here, represented with help of Venn diagram. Set B here. Okay. Set A contains 9, 16, 25. Set B contains minus 3 plus 3, minus 4 plus 4, minus 5 plus 5. And 9 is related to 3. So 9 and minus 3 will related with help of an arrow diagram. Again 9 related to minus 3. So this is the arrow diagram method to represent relation. Okay. Means the elements which are related will be linked with help of an arrow diagram. Okay. Relation to represent kariba three method: roster method, set builder method, arrow diagram method. Roster method कौन करिबा? All elements लिखिबा. Set builder method कौन लिखिबा? कोई formula टे लिखिबा जे के relation को represent करिबो. Arrow diagram रे arrow mark देकरी relation को लिखिबा. Let go to set भाबिली 9, 16, 25. Another set B भाबिली 5, 4, 3, minus 3, minus 4, minus 5. Set A रो set B को गोटे relation मु तैयारी करली but define kali set कौन से relation रे define kali na elements of set A is square of the elements of set B. Okay, so as elements of A is square of elements of B देइछि तेणु ताकु मु जदी एलिमेंट गुडा को लिखिबी क्लियरली 9 is square of 3 and 9 is square of -3 तेणु रिलेशन सेट भितरे 9 3 and 9 -3 लिखिबी 16 4 and 16 -4 लिखिबी 25 5 and 25 -5 लिखिबी जेहेतु all elements लिखिबी this is the roster method. And now दिबा set builder को फॉर्मूला तैयारी करबा set builder लिखिबा स्टाइल एमिति set contain elements a b माने this set भितरे ऑर्डर पेयर गुडा प्रेजेंट जहा को हम सिंबलाइज करबा elements a b such that a is equal to b square. Okay, माने first set element is equal to square of the second set element where a belongs to capital A, b belongs to capital B. This is the set builder method, but formula रे relation को represent करे. And arrow mark में help represent करे. This is the arrow diagram. Very simple. These are the different methods to represent relations.
Now pause the video and write the note. Now pause the video and write the note.
Students, now we will discuss domain and range of a relation. So look at what the definition of domain and range of a relation is telling. The definition is, let R be a relation from set A to set B, then set of all first components or coordinates of the order pairs belong to R is called domain of R, and the second and the set of all second components or coordinates of the order pairs in R is called range of R. So look at what is the definition is telling. Definition is telling is meaning of conclusion of the definition is we know relation set R contains order pairs AB. The set of all first constituents of the order pairs are called domain, and the set of all second constituents of the order pairs is called range. For example, consider a relation defined from set A to set B, where set A is equal to 1 2 3 4 100 and set B is equal to 1 2 3 4 5 and the relation is given by A related to B implies A is equal to BQ. Now this relation can be written in roster form. In place of B, I can use 1, 2, 3, 4, 5. In place of A, I can use 1 to 100. So if I will write 1, 1, 8, 2, 27, 3, then they obey this relation. A is equal to BQ. Now domain of this relation represented by R is given as 1, 8, 27. Definition of domain explains that domain is the set of first constituents of all order pairs. That is 1, 8, 27. This is the domain set. Similarly, range is represented by this way. What is range? It is the elements present in second constituents 1, 2, 3. What is range? Range is the elements present in second constituents of the order pair. So for this relation we get domain is 1, 8, 27. Range is equal to 1, 2, 3. Domain and range can be represented mathematically. Domain R is equal to set containing elements A such that AB belongs to relation R. If order pair of the relations are represented by AB, then all values which is suitable to become A will form the domain set. Similarly, mathematically, range R can be written as set B such that AB belongs to R. So all elements present in B, okay, all elements which can present in B will be the range set. And here a small confusion students do, that is what? If a relation is defined from set A to set B, then they think that set A is domain and set B is range. Very important mistake done by most of the students. In most of the questions it is given R is a relation defined from set A to set B. Then don't think that set A is domain and set B is range. Domain and range depends upon the relation. For example, look at the example here. Set A is equal to 1 to 100, B is equal to 1, 2, 3, 4, 5, but domain is equal to 1, 8, 27, range is equal to 1, 2, 3. So if R is a relation dependent from set A to set B, then domain can be subset or equal to A. Domain can be a subset of A or also equal to A. Similarly, range can also be subset or equal to B. Okay, so this is subset or equal to symbol. Okay, now in this case, another term codomain is coming. What is codomain? If range is not equal to B, range may equal to B or may be the subset of B. So in this relation, if range is not equal to B, then set B is called codomain. Also, if range is equal to B, then also B is called codomain. But here codomain is equal to range, here codomain is not equal to range. So this example can better explain you what is codomain. Which domain codomain kotha asila. Domain ro definition kochi relation set ro all order pair ro first constituent guda ko neiki जो set टा form habo, that is domain. Similarly, relation set ro all order pair ro second constituent गुड़ा को नहीं कि जो set टी form habo, that is range. For example, set A is equal to 1 to 100 milli, B is equal to 1 to 5 milli. Put a relation को define करी A is equal to B cube and put a relation को लिखी भी. Clearly, this is a relation. This relation रो domain माने relation भीतर थीबा all order pair रो first element गुड़ा को कुने की जो set टा लिखी भी. Similarly, all order pair रो second constituent বা second coordinates को नहीं की जो relation टा लिखी भी. Okay, so पिलाने order pair रो first constituent गुड़ा को नहीं की domain दिया गया. Second constituent नहीं की range दिया गया. Now domain और range को हमें mathematically लिखिवा domain of relation is equal to a set which contain elements A such that AB belongs to R. What does it mean? The relation भीतर थिबा order pair गुड़ा को हमें यदि AB रे represent करिवा ताहले सब A value गुड़ा को domain हबो, सब B value गुड़ा को range हबो. एटी गोटे कंफ्यूजन अछि पिलामानक मनारे if R is a relation defined from set A to set B ताहेले पिलामाने भावंती सेट ए टा होची डोमेन और सेट बी टा होची रेंज से दिन पिला माने एई सब एग्जांपल्स देखि हम जानि परछे डोमेन सेट ए सते इक्वल भी करबो सबसेट भी करबो रेंज भी सेट ए सते इक्वल भी करबो सबसेट भी करबो दिस सेट बी इज आल्सो कॉल्ड कोडोमेन रेंज कोडोमेन से तो सेम भी पारे रेंज कोडोमेन से तो डिफरेंट भी पारे फॉर एग्जांपल लुक एट हियर रेंज r is equal to 1 2 3 so here set b is equal to 1 2 3 4 5 range r is equal to 1 2 3 so range r is the subset of set b in this case b is codomain r is range
Now pause the video and write the note.
Students, now the point is inverse of a relation. So look at if A and B are two sets and R is a relation from set A to set B, then inverse of this relation represented by this symbol. This is also a relation from set B to A and this inverse is obtained or mathematically given as order pair BA if AB belongs to R. This is the mathematical definition. If R is a relation from set A to B, inverse of this relation is this symbol and it will be a relation from set B to A and mathematically if AB belongs to R then R inverse is equal to BA. Means if we will change the place of the constituents present in the order pair then we will get inverse relation because if AB present in R then BA is present in inverse. Okay, very simple. If a relation R is equal to 1, 2, 3, 4, then its inverse will be a relation 2, 1, just changing 4, 3. This is the definition. If AB belongs to R, BA belongs to inverse. I have given a simple example and clearly if R is a relation from A to B, then R inverse is must a relation from B to A. Another important thing is about domain and range with respect to this relation and its inverse. What is it? Domain of R is equal to range of R inverse. Range of R is equal to domain of R inverse. Clearly, look at here. What is the domain of R? Domain of R is equal to 1, 3. And what is the range of R? Range of R is equal to 2, 4. Okay. Similarly, what is the domain of R inverse? Domain of R inverse is equal to 2, 4. And what is the range of R inverse? Range of R inverse is equal to 1, 3. So clearly, domain of R is equal to range of R inverse and domain of R inverse is equal to range of R. Very simple. Okay. Now we will discuss some questions based on these theories. Okay. Look at the first question. Assume that A is equal to 1, 2, 3, 14. Define a relation from A to A. Define a relation from A to A given as R is equal to xy such that 3x minus y is equal to 0 such that x, y both belongs to A. Relation is given in this method. Find range, domain, codomain. Okay, students? Very simple example. A is equal to set A is given. R is a relation from A to A. means R is a subset of A into A. If R is given in this formula, here R is given in set builder form, xy such that 3x minus y is equal to 0, then we have to write the relation and find the domain, codomain and range. Now look at x belongs to A, y also belongs to A. So in place of x, I can apply 1 to 14. Okay. Then we can get the y. So look at, according to question, y is equal to 3x. So y is equal to 3x means in place of x I can put 1 to 14. So y will be get, or values of y obtained will be 3 into 1 3, 3 into 2 6, 3 into 3 9, 3 into 4 12. If we will put 5, then y the value will be 15. If you will put 5 in place of x, then value of y will be 15. Similarly, if you will put 6 in place of x, then y will be 18. So if I will write this relation set, then what I can write? First come to, if x is 1, y is equal to 3. So I can write 1, 3. In this formula, if x is 1, y is equal to 3. So first order pair is 1, 3. Second order pair is 2, 6. Third order pair is 3, 9. Fourth order pair is 4, 12. This up to this it is okay, because all first constituent and second constituent should present in set A. Now if you will write here 5, 15, then there will be a problem, because 15 is not present in set A. Got the point, students? If I will put 5 in place of x, then I will get y is equal to 15. So logic is there to write 5 and 15 order pair in the relation set. But we have to look another condition here. X, y both belongs to A. 15 is coming in place of y, which is not present in A. So this order pair is not included in relation. Okay. Got the point, students? Condition is both A and B, or both x and y should present in set A. Now, what is the domain coming? The domain coming is 1, 2, 3, 4. What is the range coming? The range coming is 3, 6, 9, 12. And what is the codomain coming? The codomain is this set. Here range is a subset of A. Here first set is A, second set is also A. So the second set is called codomain. So here codomain is equal to set A, that is equal to 1, 2, 3, dot, 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 14. Okay? Clear. Which part set A देइछि 1 to 14. आर गोटे रिलेशन कहिछि सेट A रो सेट A, माने सेट A रो सेट A माने R is a relation of A into A, and देइछि कोन रिलेशन ता R is equal to xy such that 3x minus y is equal to 0. हमको रिलेशन ता फाइंड करिबा, देन डोमेन रेंज कोडोमेन फाइंड करिबा. तो क्वेश्चन कोछि 3x minus y is equal to 0 माने y is equal to 3x, y is equal to 3x आसिला. now x जगह रे कोन पुट करि परबी 1 to 14 सब किछि पुट करि परबी. सो x जगह रे 1 पुट कले y आसीबो 3, 2 पुट कले 6, 3 पुट कले 9 एम आसीबो. सो ऑर्डर पेयर गुडा को लिखि लिखि जिबी. x जगह रे 1, y जगह रे 3, x जगह रे 2, y जगह रे 6 एमे ऑर्डर पेयर लिखि कि 4 12 लिखि. तापर x जगह रे 5 पुट करि परबी, but x जगह 5 पुट कले y 15 आसी जाउची, which is absent in set A. तनो 5 15 रहिबनी, तापर ओ किछि भी रहिबनी. सो डोमेन रेंज एंड कोडोमेन आसीला. ओके स्टूडेंट्स, एमिति आउ दु तीनोटी क्वेश्चंस देछि, ट्राई करिवो, देन सॉल्यूशंस देखिवो, क्लियरली बुझी पाइबो.
Now pause the video and write the note. Now pause the video and write the note. Now pause the video and write the note.